So every node in the cluster knows what the other nodes are doing at any one point in time, and we have multiple capabilities for that heartbeat. So there are three different ways of doing it, and you can have multiple instances of each. RSF1 supports this configuration, which is active-active, but it can also do active-passive, and it can also do N+1, but we'll talk about that more. And RSF1 is dealing with all comers, really. It's dealing with block level, database level, application level, middleware. It can do all of that. So RSF1 minimizes downtime because when you've got some, you could have a campus-wide cluster or a city-wide cluster. We could deal with an environmental issue in that way. It deals with software issues to the degree it reduces those, because if you have a failure on one node, you can continue the service on the other node. With the caveat, of course, that you don't hit exactly the same software error on the other node. It helps you escape from those embarrassing human errors. Again, because it's any form of failure, you get 2 shots at it. It can be part of your planned maintenance strategy. So when I install patches, I migrate all the services to one node, I patch the other node, and then I migrate services back. So it becomes part of the way you think. A highly available cluster is part of the way you think in your maintenance schedule and your planned outages. And of course, it's eliminating those single points of failure in the hardware. Okay, we've only been going half an hour. I feel I need to slow down a bit because we have met the midpoint in the presentation. This is just a breather. Because we're not supposed to do anything commercial here. This is all about discussion and technology and so on. When I was at Sun News, they had the .com, we're the .in.com, and they also had Network, the dog who brings the paper to you. Go figure. And there was an internal T-shirt along these designs. So I just thought I'd leverage that this morning, just for a little light relief. Just let you enjoy it for a moment. Let's look at RSF1 capabilities a little bit more specifically. RSF1 can provide highly available block level services, block level storage, in terms of ZFS ZVols with iSCSI and Fibre Channel over using the Comstar framework. And there's work that we've done to make that work, to make that jive. Of course, file-level services with ZFS, NFS, CIFS, and even AFP. That's all possible with RSF1. And at the database level, a list of databases as long as your ARM, including some very big players and important players. All the major players, I think we have to say. And it's also providing a framework so that we can even add applications to the RSF1 framework. So there's an agent framework where you can build your, if you've got your XYZ application and its middleware, you can bring all that under the control of RSF1. Basically the slogan is that if your OS can run it, we can cluster it. Bold claim. Paul will defend this claim in the break. Also, what I should say at this point, do you want to stand just to model? Grenville, could you just stand and model this? Grenville is modeling the polo shirt. The secret knowledge that you have being in this room is that they are stacked on the table, but you can just take one. Everyone else has been too polite, but please take one. And there are various sizes. As attendees to this session, you're more than welcome. So use that knowledge before you pass it on to those who didn't come this morning. Thank you, Grenville. In terms of what RSF1 can do, it also runs on just about every Unix you can imagine. It can cope with a large number of storage protocols, and it even does things like Veritas Volume Manager and the Sun Disk Suite environment. Of course, it does ZFS. It's actually quite important that we understand this, that there are smarts, there's intellectual property in RSF1 that makes this work. How do you manage mutual exclusion within a particular storage framework? That's actually one of the smarts that RSF1 has, and it does do it in ways different to Veritas and Sun Cluster. We're quite proud of. It also runs under and can manage various virtualization environments. So you can have your VMware host managed itself by RSF1, and then you can have the guests within VMware using RSF1 to manage their services as well. We've also mentioned the heartbeat technology. Today it's using, in Exento, we have to use a dedicated disk drive, so it's one that you can't use for any other purpose. But we are moving to use any of the VDEVs in your ZFS pools as heartbeat drives, because there's space in there that we can use for that, which means you get the disk drive back and you can have more than one heartbeat device, and that will be coming as a feature real soon now. Yeah. 3.1. The man says 3.1. Of course, any forward. I know I went for Sun now. I don't have to think about forward-looking statements and yeah. Okay, in terms of what it can do, you can have failover, obviously automatic, otherwise it wouldn't be highly available because you need it, somebody to push the return button. But you can also do manual failover, and it's failover. And where you're managing multiple services in a cluster, the manual automatic switch is per service, it's not per cluster. We can do active-passive, active-active, M+1 up to 64 nodes in a cluster. It's pretty cool. And your cluster can be asymmetric, so you could have a Sun M9000 64 512 core system, and you could have an M5000 as the other node in the cluster if you had one application that you cared about more than anything else. Of course, you're not going to run everything on the M5000, but you can have an asymmetric configuration. That's something that other cluster vendors don't support. If it makes sense, if you can actually get meaningful performance from that cluster, then sure, you should be allowed to do that. Yeah. Mutual exclusion relies on fail-fast capability in the driver. And you may have heard, has anyone heard the term stoneth? What does it mean, sir? Shoot the other node in the head. We know, of course, immediately that stoneth must have been invented as an acronym in the United States. In the UK, we would never think in those terms. Sorry, I have a very dry sense of humour, and it's not working. Shoot the other node in the head, and you can actually buy hardware to do this, which is basically I will cut the power to the other node. It's a fairly drastic approach, but it's because the issue we're dealing with is we can't have two systems modifying the shared disks together, so we have to have a mutual exclusion. We came up with this term yesterday in the room, which is Smith. Shoot myself in the head. Which is basically, if I detect that somebody is using the drives that I think I have exclusive right to, then I shoot myself in the head. And our mutual exclusion model is based on that. Our protection model is based on that. And it relies on the kernel spotting the instant that that happens. And it says, well, I better not do anything else. So at this moment, I'm going to panic the system and I will reboot. And when I come up again, I'll be very careful about what I'm doing. One of the things you have to be aware of in clusters is you can have a ping pong, which is like both nodes keep going up and down. Well, we guard against that. So there's quite a lot of smarts in RSF1 to deal with this. So we use Smith, not Stoneth. And the framework is extensible to multiple virtual IP addresses. Each service is given at least one virtual IP address. In Nexenter it is one IP address, but in RSF1 you can have more than one virtual IP address, and so the service has an IP address associated with it. So if you're an NFS service, there'll be the Z pool behind the NFS service, and when the Z pool moves over, the NFS service and the virtual IP address moves across. So I should have probably, the same would apply in iSCSI and in CIFS and so on.
Isn't Nexenter limited to a node system?
The question is Nexenter limited to a two-node system? And the answer is yes, it is. RSF1 is not limited to a two-node system, but Nexenter is. We'll explain that. Thank you. We'll explain that. So with RSF1, you can build very, very complex. This is only a 4-node cluster, but you can build very complex clusters. We're talking about building an Nexenter appliance that is highly available. And so at this point, in answer to your why, I invoke the keep it simple, stupid reply. If we're serious about availability, we need to be very sure of our foundations before we move forward. And so what you will see with the HA plugin is we will add more and more functionality and more options over time, but there's a big danger in allowing you to do everything at once. It is the here's a load of rope, go and hang yourself. Nobody can have tested all those options together if we let you do that. So what we would rather do, with our 15 years of seeing other people hang themselves, we sort of just suggest that actually restricting it to a two-node cluster, either active-passive or active-active, is a good thing at this time. Yeah? I just suspect that some people in the room want it to be cheap as well as good and fast. At the moment, we're trying to avoid the scenario of the 4 a.m. call, because it was so complex that somebody didn't understand quite how you'd configured it and the implications. So we think the simple two-node cluster is the place to be at the moment. And we will listen. Come and talk to us in the break if there are things that you can't do today that you want the HA plugin to do. Come and talk to us. We're going to be around these 2 days. We've got business cards on the table there. Take a card. Come and have a chat. And we'll listen. We're the sort of company that can do that, and we've got a lot of experience in this. So we'll tell you when you are being stupid. We've noticed that.